All right, get ready to have your mind blown wide open because today we are taking a deep dive, no, like a really deep dive, into the unbelievable world where quantum mechanics and general relativity collide. You've provided some pretty wild sources for this one, and I gotta say, they've left me thinking we might be living in the universe's biggest, most mind-boggling mystery novel.
Well, you see, the real head-scratcher is that these two cornerstones of modern physics, right? They each work amazingly well on their own, but when you try to bring them together, complete chaos. It's like they just absolutely refuse to play nicely.
Like trying to fit two puzzle pieces together that just weren't made for each other. And we're not talking about some minor differences here. I mean, we're talking about things like calculations for dark energy being off by a googol, a 1 with 100 zeros after it.
Yeah, that's not just a rounding error, is it?
Yeah.
But you know what? These kinds of clashes in physics, these are the things that get us really pumped. They tell us there's something big we're missing, some new physics waiting to be discovered.
It's like realizing that the answer isn't finding that missing piece of the puzzle. It's realizing we've been looking at the puzzle the wrong way this whole time. And one of the most fascinating pieces of this cosmic puzzle has to be this idea of supersymmetry. It says that every particle we know has a secret twin, a superpartner, like a selectron for an electron, a squark for a quark. Seriously, who comes up with these names?
I know, right? Sounds like something straight out of a comic book. But trust me, the concept itself is far from childish. Supersymmetry tries to address these inconsistencies and mysteries in the standard model of particle physics, which is our best shot at describing the fundamental building blocks of the universe. And here's the kicker. One of these theoretical particles, this hypothetical superpartner, it lines up perfectly with what we know, or rather what we don't know, about dark matter.
Wait, hold on. So if supersymmetry is right, we could be swimming in a sea of these hidden particles that hold the answers to some of the universe's biggest secrets.
You got it. And the most mind-blowing part is that we might not even be able to detect them easily because they interact so weakly with regular matter. That's the challenge, though, isn't it?
It's like trying to find an invisible elephant in a dark room. You know it's there, you can feel its presence, but you can't quite put your finger on it.
Exactly. And we are using some pretty incredible tools to try and find it. Like the Large Hadron Collider. It smashes particles together at mind-blowing speeds, hoping to create these supersymmetric particles. We're talking a cosmic game of hide-and-seek here, with our understanding of the universe hanging in the balance.
Okay, but just for a second, what if dark matter isn't a particle at all? What if it's something even weirder, something that plunges us even deeper into the quantum realm? Speaking of weird and quantum, have you ever heard about entanglement and those theoretical tunnels through space-time wormholes?
Yeah, wormholes. Now we're getting into some seriously mind-bending territory. What sparked your interest in wormholes, especially in relation to dark matter?
Well, the material you provided, it suggested that some physicists believe wormholes could be created by quantum entanglement. Imagine that it's not just particles that are linked, but actual space-time itself, across unimaginable distances. And if that's true, could that explain how gravity from other universes is leaking into ours?
You're onto something with the brane universe theory. It proposes that our four-dimensional universe is just one brane floating in a higher dimensional space. And guess what? This space could be teeming with other branes, other universes parallel to ours. And some physicists believe that what we perceive as dark matter could actually be the gravitational pull from matter on these other branes, bleeding through these wormhole connections into our own universe.
Oh, hold on. So our universe is like a sheet of paper, and there are other sheets, other universes right beside ours, potentially messing with our gravity. That's kind of a wild thought.
Wild, for sure. But it's not without its problems. You see, if gravity for other universes is leaking into ours, we should be seeing some weird effects, like deviations from Newton's law of gravity.
Yeah.
And so far, nothing.
So we're still missing some key pieces of the puzzle. But who knows? Maybe these missing pieces are the ones that will force us to completely rethink our most basic assumptions about how the universe works.
Now you're talking. And that brings us to one of the most exciting examples of physicists questioning those very assumptions. The case of the cosmological constant.
The cosmological constant. That's the thing Einstein called his biggest blunder, right? What's so fascinating about it?
Yeah, Einstein wasn't too happy with that one. He initially introduced it to represent a force opposing gravity, trying to make his equations describe a static universe, which was the popular belief back then.
Oh, right. Back when everyone thought the universe was just chilling, not expanding or anything.
Exactly. But his own equations kept hinting at a dynamic universe, one that was either expanding or contracting. The cosmological constant was his attempt to reconcile his math with the prevailing view.
And then Hubble comes along and throws everyone for a loop, showing that the universe wasn't static at all, it was expanding. So Einstein ditches the cosmological constant, end of story, right?
Not quite. Just when we thought the cosmological constant was relegated to the what-if bin of physics history. Astronomers in the late 1990s made a pretty mind-blowing discovery. The universe's expansion isn't constant, it's accelerating.
Oh, come on. Now the universe is just showing off. So what's causing this cosmic need for speed? What's fueling this acceleration?
Well, the current understanding is that it's this mysterious force called dark energy, permeating all of space. It's like anti-gravity pushing everything apart faster and faster.
Okay, I see where you're going with this. We're trying to make sense of this accelerating expansion, this dark energy, and suddenly Einstein's biggest blunder is back in the game.
Bingo. It turns out that the cosmological constant, initially meant to describe a static universe, can, with a little bit of tweaking, describe this repulsive force, this dark energy, driving the universe's accelerating expansion.
So, Einstein's mistake might actually be one of his greatest insights. The universe loves irony, doesn't it? But hold on. If the cosmological constant is back in play, and it's supposed to be a constant, how can it explain something as dynamic as an accelerating expansion? Shouldn't a constant, remain constant?
Now you're asking the million-dollar question. That's what has physicists buzzing right now. You see, recent research has started exploring the possibility that the cosmological constant might not be as constant as we once thought. What if it's changing over time, influenced by some unknown field or mechanism?
Whoa, so now we're not just questioning the universe, we're questioning the very rules we use to understand it. My head's spinning.
I know, right? It's a pretty wild concept. It's like realizing the ground we're standing on might be a lot less stable than we thought. But that's the beauty of scientific exploration, wouldn't you say? The more we learn, the more we realize we don't know, and it forces us to question, explore, and stay open to possibilities that challenge our understanding.
It really is amazing, isn't it, to think that some of our most basic assumptions about the universe could be completely wrong.
Absolutely. It just shows how powerful human curiosity can be, this drive to understand, even when the answers keep getting stranger and stranger.
One of the most mind-blowing ideas I came across in the research for this deep dive was the suggestion that maybe, just maybe, quantum mechanics and gravity are way more connected than we ever thought. Like, we've been trying to solve this puzzle with two completely separate sets of clues, when all along they were meant to be put together.
I like that, the puzzle analogy. It really gets at why physicists are so fascinated by entanglement and wormholes. They hint at a universe that's far more interconnected than we ever thought, stranger than we can imagine. What if, instead of gravity being this separate force acting on spacetime, what if spacetime itself comes from a deeper quantum reality?
So gravity and quantum mechanics, they're not two separate things, but two sides of the same coin. That's a big shift in thinking.
It is, and it's led to some really wild theories like quantum gravity, trying to unify those principles of quantum mechanics with what we know or think we know about gravity. It's like searching for the universe's instruction manual, trying to crack the code.
A theory of everything. I mean, that's like the holy grail of physics. It's almost too much to get your head around. But then again, 100 years ago, black holes and entanglement, those probably seem just as crazy, right?
Exactly. We're constantly pushing the limits of what we think is possible, and that's what makes this whole journey of scientific discovery so exciting. As we gather more data, refine our theories, who knows what we'll find.
Well, as we wrap up this deep dive, I gotta say, I'm kind of overwhelmed, but in a good way. It's humbling and kind of exhilarating to realize how much we still don't know about the universe.
Hold on to that feeling. It's that curiosity, that willingness to embrace the unknown that's going to keep us moving forward, keep us asking questions and searching for answers.
Couldn't have said it better myself. And to everyone listening, keep those questions coming. Keep exploring and never lose that sense of wonder because the universe is full of incredible mysteries just waiting to be uncovered.